Hey everyone, and welcome to the fifth part of this workshop, where we will be using API calls to receive blockchain information. We'll be learning three major things from this video. The first is to try to understand why we need an API to query the blockchain for information in the first place. Then we'll look at the documentation on how to use the API to query the information we need. And finally, we'll look at how we can parse the data and perform computation on the response we get from the API to get the desired information. So on opening the lab, we will see a similar setup with the files on the left, the text area to write code in the center, the output window on the right, and the terminal at the bottom. Now for this particular lab, we actually won't be needing the output window. So we'll just get that out of the way. So the first thing we need to understand is the need for an API to call this blockchain data. This is because whenever we are writing a front-end application which uses the blockchain, we need a programmatic way to check for certain events. And let's look at it from a variety of examples. Let's take the first example where we saw in the second video of a status dashboard which is able to show the last block which has been published. In order to do that, we need to have an API which calls for the latest block number. So let's create a simple piece of code which shows us exactly that. The first thing we'll go to is the API docs, and it will show us the API information for all of the APIs which the XDC network has exposed. The first one we look at is block number. Now block number returns exactly what we need, which is the number of the topmost block. And they've also provided little code snippets to get started easily. So what I'll do is I'll copy this code snippet directly and paste it over, and we can then run it directly, but we'll face a little issue, which is that we don't have XHR enabled. So to enable that, we need to install npm, we need to install XHR2 using npm. And once that's done, then we need to set it as one of the variables. So we'll do that now. Great, now that has been set, and let's just run the code and see what happens. So we run node index.js, and we can see that it's written some information about this particular blockchain. So this actually this console log has happened through here. So let's quickly change it up. Let's create a variable called JSON response and assign it the JSON parsed value of the text which we have received from the response. Let's just console this out for the time being and see what response we get. It will be the same response. It will just look a bit better. And now we see that we want the result of the JSON value. So JSON response.result. This will give us the hex value of the of the block number, which is the latest block which has been published. So in order to convert this hex value to integer, we need to parse it as an integer. So parse int comma 16. The reason we add 16 at the end is because that tells us the base. So if this was binary, we would add 2 there. Or if it was like a normal number, we would not add anything, but if we wanted to, we could add 10 there. And here we go. It tells us that the topmost block right now is 41589847. Now, if we wait some time and if we call this API again, it will tell us that the number has increased, which makes sense because the blockchain is creating blocks at a constant rate. So the block number is just going to keep increasing over time. Now, as I said, this is a very useful API because it can be used if you want to create a dashboard or if you want to show the last block, or even if you want to create a particular operation every time, let's say the thousandth, like every thousandth block is created or something like that. That is where this particular API can come in handy. But what if you want to see the difficulty of a particular block? An example of where knowing the difficulty would be useful is if you want to analyze how difficult a particular blockchain is increasing over time. So this can help you actually make a decision of whether you want to set up mining equipment to mine a particular cryptocurrency, because the profit or loss you make will depend very strongly on how the difficulty of a particular chain increases over time. So to do that, we can go back to the API docs and we can look for an API called get block by number. So let's just scroll down. Get block by number. So this will tell us the information about a particular block. Let's again copy this whole piece of code and paste it in without removing the first line. Once that is done, this is the block number which it is searching for. So again, let's create a variable called JSON response, which is equal to this dot response text, and console log it, and let's see what happens. We need to JSON parse it to make it look better. Yeah, so as we can see, it's returning all of this information about the zeroth block, which is the genesis block or the first block within a particular blockchain. So if we want to find out the information of a particular block, like let's say the 10th block, let's create a variable for that. So var block number is, let's say, 100. We want the 100th block. Then we need to convert this to a hexadecimal value first. So var hex block number is equal to, we'll have to convert this to a string first. So block number dot to string, and we'll need it to be in hexadecimal, so in base 16. That's why we're adding 16 here. And we'll also need to prefix this with 0x, because as you can see, we're not able to just pass in 0. We have to prefix this with 0x. So 0x plus block number dot to string. Now let's replace this with hex block number, and within the JSON response, for the time being, let's just return number. Cool. So let's run this now, and it is not showing it for some reason. Okay, got it. Why it's not showing the number? That's because this is nested within result. So we'll have to do JSON response dot result dot number. So if we run it now, it will show us that the number is 0x64, which actually, if you convert with the 16 base, is going to be 100 anyway, which confirms that the API call which we're doing is working. So again, to just confirm the difficulty that we want, we can look at the total difficulty here. So total difficulty is the information which we want from this API call. And we can see that it was 0x12b. Now again, we need to be able to read it as a human. So we need to parse it as an integer with the base of 16, like we did for the last one. We can see that the difficulty here was 301. So this is a very interesting way to, let's say, plot a graph. You can probably run this in a for loop, which goes from block number 1 to the last block with increments of 1000 blocks, and you can plot a line graph to see what the difficulty was at 100 and 1000. So let's just take a quick look at that. If the block number was 1000, then the difficulty was 3001. If the block number was 10,000, it was 73,801. And as we go more, it will increase exponentially. So it will go to 917,401. So you can see that the difficulty of this particular chain has been increasing exponentially over time based on the block numbers. But this is also because we have been increasing the block number in exponential increments, like we've been multiplying it by 10 every time. So then it actually might be a linear correlation. So to do that, we'll have to create a line graph and analyze it. And based on that, we can create some conclusions on whether the difficulty is increasing at too much of a rate, or whether it is increasing at a rate which is not enough for the growth of this particular blockchain. Finally, let's take an example of seeing if a particular transaction is completed or not. And that is extremely important, because if you have a front end which performs transactions for you, then you want to perform, let's say, further processing or give the client confirmation of whether a transaction went through or not. And these certain decisions can only be made if you give an API call to the blockchain and it tells you whether a particular transaction was completed successfully or whether it failed. So to do that, let's go back to our documentation and we look for something called get transaction receipt. This tells us the information about a particular transaction, and the major thing we're interested in is the status. So whether it was giving us a success status by telling us it was 1 or 0. So just like last time, we'll copy the code and we'll paste it in here. Now there is one little change which we'll have to do. In order to test whether our transaction which happened here is like has worked or not, let's first copy the transaction ID and paste it in, because that is the one we are testing against. But if you remember, we ran this on the test network. So the URL which we need to query should also be the test network. So that is this. Finally, let's just run this and see what happens first. Okay, so we can see a lot of information about it. To make it a bit easier to read, let's convert this into a JSON variable. Okay, and console log this. Cool. Let's see what this shows. Great. So we can see information about the transaction we were looking at, and what we were interested in was the status. So it is showing that the status is 1 right now. And that is really important, because now what we could do is, let's say we have an app, we can query this, like every transaction that goes through it, and check for the status. So the way we could do this perhaps is, let's say we have the JSON response. So JSON response dot result, I think it's within result. Yeah, it's nested within result dot status. Let's print this out and see that it gives us 0x1. Great. So we need to parse it as an integer, and since it's a hexadecimal value, we will again give it a 16 radix for the conversion, and it's giving us 1. So we could have something as simple as var success result is equal to parse int this, and then we could just check with a ternary operator whether if this was 1 or not. If it is 1, then we say successful, or we say failed, and then we just console log the success result. Great. And it shows that it was successful. So this is a really interesting way to look at how to use the API, because if you had a front end which required the success or failure value of a particular transaction to make decisions on the front end, this part could just keep running in a loop for all of the transactions that are going through your app, and based on the value of successful or failed, you could make those decisions on the front end. So yeah, this concludes our 5th video of the workshop. I'll just quickly recap what we've learned and understood. So we first understood why an API's access to a blockchain's data is important, and we saw some of the use cases which leverage the API exposed by the blockchain. We also understood how to parse and use the information received from these API calls by an application, which will then be built on top of the blockchain.